Welcome to PVS the TUTOR. Today under physics we look at magnetism. Now when we talk of magnetism, we are talking about the attraction and the repulsion of magnets. Now we know that a magnet has got a north pole and a magnet has got a south pole. And what we need to know that the electric field or the magnetic field, they flow from the north pole going to the south pole like that. So we look at the law of magnetism. It states that same poles repel, while opposite poles attract. What we mean actually is, what we mean by same poles repelling and different and opposite poles attracting is, if this is the north pole and this is the north pole, probably these two poles are going to repel because they are the same. So since magnetic field, they'll go like that, so magnetic field will be going like that, even for that one will be going like that. So these two are going to repel. But if we say we have, even when you have south and south, the poles will be coming in here and the poles will be coming in here. Even for this one, the poles will be coming and the magnetic field line will be coming. So they're going to form they're going to leave a space there and a space there, and this space is what we call the neutral point. That's what we call the neutral point. So it's called the neutral point because there is no magnetism that takes place. There is no any magnetic effect there that is occurring. There's no magnetic field lines passing through. So those are some of the reasons that we can give. So let's see how we can draw the magnetic field lines on magnets. So let's say drawing of magnetic field lines. Now, if this is a magnet, north, south, and this is another magnet, north, south. So before we go anywhere, let's first draw magnetic field lines on a single magnet. So field lines on a single magnet, like I said, they move from the north pole going to the south pole. So they're likely to go like that, also like that, like that. Make sure they don't touch each other. Even as they are starting from one point, make sure they don't touch each other. So that's how grammatically we can show the movement of magnetic fields from the north pole going to the south pole. Let's see on two magnets. Let's look on two magnets. So we have this magnet here. Have this magnet here. North, south. And this magnet here. North, south. So all these lines are going to be, of course, they're going to move from the north going to the south. Now see how I can do this. So from north going to south, from north going to south, also from north going to south, also from north going to south. Now, since there are also two magnets, they are parallel to each other, of course you expect also lines to go from there going there, lines going there to there. So it can be shown like that, like that. Like I said, make sure they don't touch each other, the lines. So of course some lines will come also from north pole there, from there going to the south pole there. So that's how you can draw the magnetic field lines on two magnets that are adjacent to each other. Let's see how we can draw the magnetic field lines on two magnets facing each other with the same poles. Yeah. So look at magnets facing each other with the same poles. South, north, north, south. So from north going to south, from north going to south, north going to south, north going to south. Even here they move from north going to south, even here north to south, north to south, north to south. So I'm going to discover that here there will be no magnetic field lines. So they are going to form the neutral point, because at this point there is no magnetic effect or magnetic field lines passing through. That's why it's called the neutral point. Now let's look at magnetic field lines in a solenoid. You know that a solenoid is a coil that is wrapped around a magnet. So if this is a magnet, then the solenoid probably can start from there like that. I'm sure you've seen this before. Then this solenoid is connected to a current, a source, okay? And there's a voltmeter somewhere there with a deflection, either going right or going left. So if this is a positive, for example, and this is negative, so current will always move from positive going to the negative terminal. So the same way current is flowing from the positive terminal going to the negative terminal, this will enable us determine the poles of this magnet. Now we are going to do this with the help of the right hand group rule. The right hand group rule, it's a rule that is going to help us identify the direction of current as well as the poles. Now when you stretch your thumb upwards, imagine this is the hand, and now that's the thumb, and you've got fingers here, okay? So your fingers should be folded like that, then your thumb is pointing upwards. So the thumb, it always points it to the direction of the North Pole. All the folded fingers, they point to the direction of current in the solenoid. So as current is going this way, so current is going like that. So the current will be going upwards like that. All right. So when you put your hands the other way around like this, your thumb comes this side, then your fingers comes there. This is your hand. So you discover that where the thumb is pointing, your fingers here, they are pointing upwards there, and the thumb is pointing this side. So this side becomes the North Pole. Of course, the other side becomes the South Pole. So that's a simple way you can be able to determine the direction of the current, also the poles of the magnet if you're given in a solenoid. Let's look at one simple explanation. So how can we determine the poles of X and the poles of Y? We can see where X and Y is. So we are going to use the same right hand grip rule. Now when we look at the direction of current here, it's going upwards. So of course when drawing, current is going downwards like that. And since current is going downwards, we are going to draw our grip handle like this. So the thumb will point the other way around in the right direction, and the fingers will point downwards. So if this is the hand, right? So your thumb, the fingers are going to point downwards there, but the thumb is going to point in the other direction like that. And this direction is showing the North Pole. Since the fingers are pointing downwards, this becomes the North Pole and that becomes the South Pole. So we're saying X is the South while Y is the North Pole. Thank you so much. Don't forget to subscribe, like our page also.